All right, good morning. Let me make sure this doesn't spill on my laptop. All right, good. So good morning. Thanks for coming to this talk on how to save money on your serverless architecture. So my name is Ian. I've been building stuff on AWS since 2010. So I went through the whole journey of running stuff on EC2 to containers to nowadays, I think since about 2016, I've been pretty much entirely focused around serverless. Nowadays, I spend half my time working with Lumigo, which I think is the best observability platform, especially for serverless workloads. And the other half of my time, I work as a consultant, where I help other companies adopt serverless and try to go faster. And so I also been collecting a lot of tips around how to saving money on your AWS environment, especially when you're doing mostly serverless stuff. And one of the tips I guess everyone should be using nowadays, and I'm sure the fact that this is the DevOps conference, most of you are aware that within AWS you've got billing alarms, and the fact that everyone should use them, even though they're not perfect. Usually, 4-8 hours behind real time. So you're going to find out it's a problem a few hours late, which is still much better than when you've got a problem much later, say at the end of the month when you get a bill, and it's a lot bigger than it would have been if you found out, oh, right, we got a problem that was happening. And I think I really love this story from Luc van Donkersgoed, who was a principal engineer at the PostNL in the Netherlands. So they got this alert. It all came from a one-line change they made to one of the Lambda functions. So what happened was that the Lambda function was fetching secrets from Secrets Manager, which charges you something like 10 cents per 10,000 requests. And so they had a one-liner change that broke the caching. So instead of getting it at cold start and then just caching it, they would just make a request to Secret Manager on every single invocation. So you can see pretty much straight away the cost went up based on the invocation count. And so they found out, I think maybe after, what was that, about 2 weeks, that they hit their billing alarm, the threshold is set to, I think it was 2,000. And so at that point, they realized, oh, something's up. We have to go and figure out what the problem was. Why are we calling Secret Manager every single time? So the morale of the story is that, yes, billing alarms are not perfect, but you should still definitely have them because it's much better to find out there's a problem, say, 2 weeks into it, rather than the 4 weeks or whatever months into it when you get your bill or when you get a knock on your door from the finance department to say, hey guys, what's up? Now you're starting spending X number of dollars, $1,000 per month on your AWS bill. And when it comes to cost, another thing that I think everyone is painfully aware of is the cost of observability. And this is the same, I guess this is true for serverless workloads as well as for container workloads. And the CloudWatch logs is oftentimes much, much more, I guess, costly compared to the cost of, say, the Lambda functions, your API gateways, and whatnot. Oftentimes, when I look at my customers' bills, you find that the top 3 lines would be something like, CloudWatch, and then way down the list would be Lambda and API gateway, and so on. And so, we got to do something about this because observability for many people is both expensive but also bad because people spending a lot of money on collecting their logs and metrics, but they don't really get much value from it. Oftentimes I find that as your cost goes up, because you're collecting more and more data, it's actually getting harder for you to find the information you need when something goes wrong. It becomes much difficult for teams to figure out what the problem is when something happens in production. So there's a couple of things I like to do to help my teams keep my CloudWatch logs cost under control. Number one thing, this is also helping you in terms of making your logs more searchable, is to do structured logging. And I'm sure this room here, everyone being coming from a DevOps understands why we want to do this. So you want to pay a lot of very close attention every time you write a log message to say, OK, is this a debug message? And this is something general information about what's going on in your application. If it's an error, but we can handle it, then we can log it as a warning. But if it's something that we actually just need to fail the request, then we should log it as an error, and so on and so forth. So pay attention to every single log message that you write. And then in production, you set your log level threshold such that you say, don't log anything that's debug, or maybe even want to go a bit higher than that. So that way, in production, you're not spending all this money and time just sending debug logs to CloudWatch that you're not actually going to find very useful. However, You also don't want to have no debug logs at all, because when something does go wrong, and the debug logs can be very useful for you to figure out what the problem was. And you don't want to be in a situation where you have no debug logs. So the first sign of problem, you have to first go back to your code, change the log level, deploy, wait, I don't know, however long for the problem to happen again, get the logs, and then fix it, and then remove the debug logs or move it back to whatever it was for production. So instead, you want to sample your debug logs for some percentage of user requests or Lambda invocations, such that hopefully that percentage should cover every code path you have in your application, so that when there is a problem, you always have some body of debug logs that you can use to figure out what the issue was. Another thing is that by default, CloudWatch logs set your log retention to never expire, because AWS doesn't want to delete your logs without you saying so. And this is, I guess, good on their part, but also this is probably not good for you, because you do pay for those logs retention, and the logs typically reduce. Well, they don't become they lose their value over time, and typically you probably just need to keep your logs for like the last 30 days or so. And because with CloudWatch logs, you do get charged for per gigabyte of data that CloudWatch have to store for you, even though this is relatively small compared to the ingestion cost, but it's a cost that can grow if you don't change your retention to something more reasonable. Another thing to think about when it comes to CloudWatch logs cost is that, well, if you are running a mostly serverless environment, you've got lots of Lambda functions. Those functions are writing to standard out, and AWS is going to ship the logs to CloudWatch. But then if you're using some kind of a log aggregation platform, you want to take your logs from CloudWatch and then put them into that platform, so you have one place to search across your entire AWS environment. Imagine you've got hundreds of AWS accounts, and you want to have one place where you can search all the logs. Then you probably have something similar to this, where you are using a Lambda function to ship all of your logs from CloudWatch to some other platform. The problem is that when you do this, you're being charged for ingestion by CloudWatch, and then again by the vendor that you're actually using. So you end up paying twice for the ingestion and the processing of those logs. And one thing I don't like is I don't like waste. I don't mind spending money, but I want to get return on my investment. If I'm doing something that's costing me money and not getting anything back, I want to stop doing that. So nowadays, you have the ability to use the Lambda extensions with the telemetry API. So Lambda extensions is basically a way for you to run like a sidecar next to the Lambda main process. And the telemetry API is a local API that's accessible to your Lambda extensions, such that you can subscribe to log events and the telemetry events, so that you can, in the Lambda extension, get those information and then send them to your destination platform without going through CloudWatch logs first. But when you do that, it doesn't stop Lambda from still writing data to CloudWatch logs, anything that you're writing to standard out or standard error and so on. So you can stop that by adding this couple of lines to your Lambda function's IAM permissions, so that the Lambda function doesn't have permission to write to CloudWatch logs anymore. And so you are shipping all of your Lambda logs from the Lambda extension to the platform where you're actually going to use them and query them. If you're looking for an alternative to CloudWatch, Lumigo does have a pretty good logging platform, and that's also much cheaper compared to CloudWatch logs as well. So check them out if you're interested. But there's one more thing I want to think about, because even if you are doing all the structured logging, sampling, debug logs, and so on, there's still those system messages that gets written to the CloudWatch every single time your function runs. So when it starts, when it ends, and there's also a report to tell you how much time your function ran for, how much time you actually charge for, and so on. For 99.9% of people that are using Lambda today, this is not going to be a problem. It's going to be a relatively small amount of logs you're writing. But if you're doing, say, billions of Lambda invocations per month, as is the case with folks at Fathom Analytics, even if you don't use CloudWatch logs for anything, you may still end up paying a non-trivial amount of money, because all of the Lambda system messages that gets recorded. So if you're running Lambda at scale and you're using some other platform for logging already, another thing you could do, at least consider, is nowadays you've got this advanced logging control for Lambda, which essentially allows you to configure a couple additional settings with your function. So that, one problem that we often find in the environment with clients is that the developers are not disciplined enough to be reliably writing structured logs, which makes the logs processing the pipeline more difficult to do. And so one of the things you can do nowadays with Lambda is to set the log format to JSON. This basically tells the Lambda service that in their kind of like a proxy, the daemon they're running on the Lambda instance, they will take whatever the things that you're writing to the Lambda sender out, it will wrap it into a JSON structure for you so that you've got some JSON structure logging out of the box. And annoyingly, this is tied to some other features that they also provide as well, so that when you have the log format to set to JSON, you can also then configure a log level for the system messages. This is so that you can choose which of those system messages that Lambda always outputs for you that you actually want, as opposed to just get them all the time. So if you just want to know when there's an unhandled exception in your code that it blows up the Lambda process, you still get those error messages when you set the system log level to 1. And that way, you don't get any of those nonsense log messages in CloudWatch. And then talking about Lambda, there's also, I guess, the one main thing you can do to optimize the cost of your Lambda functions, which is to right-size the Lambda functions memory setting. And for Lambda functions, you probably know this already, you have basically one lever to control the performance and the cost of your Lambda function. So more memory equals more CPU allocation and also more bandwidth allocation as well. And so this means that, OK, if you want to add more power, you're doing something CPU intensive, you can just increase the memory allocation to your function. And then once you go over 1.8 gig, you start to unlock a second CPU core. So at the maximum 10 GB of memory setting for your Lambda function, you can actually have 6 virtual CPU cores available to your code. The problem with this is that it's very convenient to control the power and the memory and the bandwidth, network bandwidth for your function, but it's also very easy to get it wrong by an order of magnitude, especially if you're not really thinking about how it's actually going to work out carefully. So here I want to share a story from one of my clients. So they do video encoding, and they use Lambda for that because they can easily scale to many tens of thousands of invocations concurrently. And one of the things that the team realized was that by default, their function had about 1 gig of memory, and it was taking quite a long time to encode those videos. And so they knew that by increasing memory, they were able to get more CPU, and so make their encoding go a bit faster. And so they went straight to 10 gig. And then when I kind of came into the client and looked at what's going on, they were spending about $10,000 a month on the single Lambda function, the one that was doing the video encoding, because it runs a lot. And every time it runs for quite a long time as well. So CTO was kind of worried that, OK, are we doing the right thing here? And the problem for them was that, OK, it's true that the more memory, the more CPU, but because once you go over 1.8 gig of memory, you get multiple CPU, and not just the vertical scaling, you also horizontal scaling as well. And that means you need to write your code in a way that takes advantage of multi-core. They were using Node.js. The team didn't realize this one specific detail about how scaling works on the Lambda function in terms of memory. So even though they were paying for 10 gig, they were only really getting the benefit in terms of CPU power for 1.8 gig, which means 90% of what they were spending was going to waste. And so we decided, OK, instead of rewriting the encoding code to take advantage of multi-core, we just, in the short term, reduce the memory to 1.8 gig, and so they were able to cut 90% of that cost for that one Lambda function, so that it's actually just you get what you pay for, as opposed to spending a lot more money and not getting value for it. And I love this quote from, I guess everyone has heard this quote before, that premature optimization is the root of all evil. But I think the second part of it is just as important, that we should not pass up our opportunities in that critical 3%. So once we find a situation like this, we want to make sure that we optimize things. Because in most cases, I find that Lambda functions is not a big cost concern for most companies. Maybe of, say, your hundreds of functions, there may be one or two of them that are actually costing you something meaningful. So that if you try to optimize a function that's costing you 5 cents, you're not going to get any return on investment. But if you're optimizing a function that's costing you $1,000 a month, then maybe there's some value there for you to do some optimization. So in the Lumigo console, you can also quickly sort your functions by cost as well, which I find really useful in terms of identifying that one or two outliers that I typically find in a customer's environment, where we want to right-size our Lambda functions so that, again, we eliminate waste. Again, I'm going to say this again, I don't mind spending money on things, but I want to get return on my investment. I hate spending money on things, and that doesn't give me any value. In terms of actually optimizing your Lambda functions, the memory settings, there's basically a couple of tools you can use. I think the best one is the Lambda power tuning tool, which is basically a step function state machine that takes your function, creates multiple copies of it with different memory settings, and then it will run that function, say, 100 times for each of its variants and figure out, based on the memory setting, how is the cost going to change, and also how is the performance going to change. Sometimes, most of the time, you're going to find that you're going to get a little bit more as you increase memory until you hit about 1.8 gig. Again, it's about when your function goes multi-core, can you still take advantage of that multi-core? But also, you find that with functions that are very I/O heavy, that spend a lot of time waiting for API call to come back, you're probably not going to see much improvement as you add more memory, because most of the things is happening. It's just you waiting for an I/O to come back. And then the thing you could do is to use the ARM architecture instead of x86. Lambda has supported ARM for a few years now, and one of the interesting things about this is that per millisecond of execution time, using ARM is actually 25% cheaper than using x86. So if your function is doing mostly just I/O waiting, then this is a great way for you to just save 25% and say thank you. But the performance can actually be very different. A launch, AWS says something like is 25% cheaper plus 90% more performant on the things that they tested on. So overall, you're probably looking at like 45% or whatever savings. But for the workloads that I've tested, the difference can sometimes be negatives, as in the ARM can be like 60% slower than x86. So you save 25% per millisecond, but you're spending 60% more time, so it ends up being more expensive. So the point is that you always want to, test the ARM against your own workload to make sure that whatever it is you're doing actually works better on ARM, or at least comparatively the same. But I think this is very good for functions that are doing a lot of time just waiting for I/O to come back, in which case, again, those are just CPU cycles that are going to be wasted, and you're paying for them, but they're not going to do much difference anyway if you're running on ARM or x86. And staying with Lambda function, probably the biggest mistake I find people make with Lambda is Lambda to Lambda invocations. And there's quite a lot of nuances to this. So I want to spend a few minutes on the specific differences. Because when it comes to Lambda functions, there's basically one API call that's important. Everything has to go through Lambda's invoke API. This is how you run whatever you code you have in the Lambda function. And importantly, there's a field called invocation type. So you can either invoke your function with request response. So this is the synchronously calling the function, and that invoke API will finish when the function finishes running. Or you can say find or forget and say the invocation type is event. So this is you invoking the function asynchronously. So your API call, the invoke API call, comes back straight away, but then the invocation goes on to an internal queue, which then Lambda is the service is gonna invoke your function behind the scenes, and you get things like multiple retries and support for delta queue or Lambda destinations and so on. And so there's quite an important difference here to consider between synchronous and asynchronous, because I think when it comes to Lambda invocations, synchronous is probably one of the biggest red flags you can find. It's pretty much always a case of bad design when it comes to Lambda functions. One of the reasons for this is because when the first function runs and it calls the second function is going to run, and you are paying for the execution time for that second function twice, because the first function is still waiting for that second function to come back. Because again, synchronous calls, you're making a call, you're waiting for it to finish, and then you get a response back. So this is no good. Again, I don't mind spending money, but I don't want to waste money on things by double paying for them. So if you've got two Lambda functions inside the same service boundary, you're just trying to be, I don't know, single responsibility functions or what have you, then don't do it. Just do whatever you're doing the two inside the same function. You can still have modularity in your code. I think this trips up a lot of people because these things are called Lambda functions. Yes, they're called Lambda functions, but you don't have to apply the same thinking to Lambda functions in programming. You can still have modularity in your own code. You don't have to split things up into different infrastructure parts that you end up paying for extra latency in terms of invocation, cold starts, and also just cost as well. OK, so that's two functions in the same service boundary. But what happens if you have synchronous lambda calls across different service boundaries? Is that a good idea? No, it's actually even a worse idea, because now you're saying to your service consumers that, hey, here's my service capabilities. If you want to use it, call my lambda function, and you're making them depend on an implementation detail. Because the fact that you are using a lambda function, the fact that you're using US East 1, or the fact that your function is called X, Y, and Z is implementation detail that your consumers shouldn't have to know about and shouldn't have to depend on. So if you want to expose some business capabilities to some other teams that they can call your service, then just give them an HTTP interface. And behind the scenes, if, say, now it makes sense for us to run Lambda, great. But if tomorrow we are running at such a high volume that is more efficient cost-wise to run them on containers, you can move your application to run on Fargate or ECS or what have you. And to your consumers, they are none the wiser because they're not depending on an implementation detail. They're calling your HTTP interface the same way that they would do if you were implementing in Java or what have you. It doesn't really matter. So that's synchronous invocations. Pretty much always lambda synchronous invocations are a bad idea. But what about asynchronous invocations? There are some particular use cases where this makes sense. I have one case that I use quite a lot is when I've got, say, some user-facing API, and user calls API to, say, save their profile. And so the primary responsibility is for that function to save the update to the user's profile in the database. But then maybe you want to do something else. Maybe you want to do some analytics tracking or call some other fixed API or what have you. Those are secondary responsibilities, so I can offload those secondary responsibilities to another function and invoke it asynchronously so that the first function can return quicker to the caller. That way, I can improve user experience. It's about reducing the user-facing latency by offloading things that the user shouldn't have to wait for us to finish so that we can then respond quicker. And also, it allows us to have more robust error handling for those secondary responsibilities. Imagine if you're, say, calling Facebook's Pixel API to do some analytics tracking for when a user, makes a purchase or what have you. If that call fails or is particularly slow for whatever reason, you don't want to fail the call to the purchase API. And so by moving that secondary responsibility to a different function, you can leverage the built-in retry, delta the queue, and so on and so forth. Again, I want to do this because this is going to help me improve user experience, even though it comes with extra cost by invoking a second Lambda function. And this is assuming that, again, two functions inside the same service boundary, because these are things that I would have done in the first function anyway. It's just that I want to, I care about user experience, and so I put in some of the things into the second function, and I use the async invocation to do that. But if you're doing async invocations across service boundaries, again, that is still not a good idea. It's just, again, you are exposing implementation details to somebody else, some other team, some other service. So, in general, are async lambda invocations OK? Again, like I mentioned, there are some valid use cases, but it really depends on specifically use case that you have. I wouldn't recommend it to, as a broad use case. I think one of the architectures, architectural principles I have is that when I look at my architecture, every component should have a purpose. They should return some value. They should have a reason to exist. If they don't really serve any purpose, then I'm very happy to just remove them. And we'll talk more about that later. But an example from the guys from Fathom is that they've got this workload where they have a Lambda function doing the ingestion, and then they put stuff onto a queue, and then the second function is going to process the thing. And what they found was that as they removed that second function and the SQS queue, things actually got faster. It was more efficient for them to actually just do the thing in that first function. And by simplifying the architecture and removing things that they didn't actually need, they improved performance, but also importantly, they saved a bunch of cost because, again, they are running at pretty high scale, and by removing the use of SQS and the second Lambda function, they actually saved something like $24,000 a year as well, just by simplifying the architecture. And talking about architecture and improving things and cost-wise, caching is probably the biggest cheat code you can have when it comes to building scalable and performant applications. And when it comes to kind of your typical serverless API, where you've got your Route 53 in front of CloudFront, in front of API Gateway, Lambda, and DynamoDB, there's quite a different few places where you can implement caching. I always want to have some client-side caching for things like static assets, config, and things that don't really change. And then I want to have some edge caching with, say, CloudFront or Fastly or Cloudflare or what have you. For anything that I'm doing in my Lambda function, anything that's compute heavy and I don't want to do them over and over and over, I will also have some application level caching as well inside my code. And so I can use something like Elastic Cache, but because I don't like to pay for uptime, again, paying for uptime means even when I'm not doing anything, I'll have to spend money, and I don't like waste. So nowadays, I actually prefer to use Memento, which has got a really good serverless cache where you only pay for the usage, so the request you're sending, as opposed to paying for uptime for the nodes. And another form of caching that we probably don't think about enough is when it comes to Route 53. I guess that by default, Route 53's TTL is set to about 5 minutes. This, again, something that probably doesn't affect most people because you don't have so many requests. But with Route 53, you are charged based on the number of DNS queries you receive. And if you have got a workload that has got really high throughput, then chances are you're going to get billions and billions of DNS requests a month. And if your TTL is set to only 5 minutes, then you may end up paying a lot more than you would do if you were set to, say, a couple of hours. Or for domains that doesn't really change, then maybe you can set TTL for a couple of hours, maybe even a day, if you know for a fact that it's not something that you're actually going to change regularly. Again, very simple thing, potentially make a big difference for you depending on how many DNS requests you receive. Another thing about architectural changes, well, things that probably don't think about enough is when it comes to cross-origin requests. With API Gateway, you can support calls really easily. It's just going to be basically one setting. You just enable it, and API Gateway is going to generate those calls endpoints, those options endpoint for you. However, you do still pay for those requests to the calls endpoints. Now, you may think, OK, that's fine. Just slap some caching in front of it, and you'll be fine. The problem is, with API Gateway, there's been a long-standing bug in terms of how you handle those request headers when you're using authorization header. So many user-facing APIs do need to have that authorization header, and the thing when you have that, it doesn't add it to the access control allowed headers list, and so that kind of breaks how the cache headers work. And so you end up, there's a very good chance that you may, if you look at your network traffic now, you may end up double paying for those requests because you're paying for those calls requests repeatedly because caching is not working the way you expect. So you can either roll your own options endpoint or method, which is not great, or you can, if you can do that, it'll be a lot easier to just move your API into the same domain that your front end is hosted on. So instead of having like api.mydomain.com, which is actually counts as a cross-origin request, you just put your API on a subpath in the same domain that your front end is hosted on. That way, it doesn't count as a cross-origin request. OK, so when it comes to AWS, probably the most useful skill set for you and for your architect to have is to understand what services to use, because in the cloud, every architecture decision you make is a buying decision. You're deciding what services to pay for and use. And when you choose the wrong service, it can end up being a very, very costly mistake. Say you're doing some event-driven stuff, you need to have some kind of messaging service between different components. You have, off the top of my head, SNS, SQS, EventBridge, Kinesis, IoT Core, a bunch of other different services, or MSK, a bunch of different services that you can use to be the messaging bus or whatever. And the way you get charged for many of these services is by request. So at 1 request per second, steady rate, Kinesis is kind of expensive because you're paying for uptime for the shards. But at a higher throughput, say 1,000 requests per second, suddenly Kinesis is very, very cost efficient compared to other services like SQS and SNS, where you only pay for the request itself. Same goes to API Gateway and versus ALB. You can use Lambda functions behind API Gateway or ALB. With ALB, the way you calculate the cost is kind of complicated, but usually when you've got a low throughput API Gateway is going to be a lot cheaper. But at scale, again, that equation flips very, very hard the other way, where API Gateway can be much more expensive. So a good rule of thumb to have on AWS is that, I guess maybe in general as well, that services that charges you based on uptime is a lot more cost efficient when you're running at scale. The good news is that for most people, they're not doing thousands and thousands of requests per second. I think most people I've seen, they're doing maybe tens of requests per second. So these kind of differences may not be as dramatic. But an important thing to think about here is that you should always understand the specific cost dimensions of the services that you're using, because even though the general rule may be true 90% of the time, it may not always be true. ALB, the example I showed earlier, that was assuming 1 kilobyte per request. What happens if you raise that to 1 megabyte? Because one of the cost dimensions for ALB is data processed. So the more data you have to return or ingest, the more it's going to cost you in terms of the ALB units. Suddenly, ALB is not so cheap anymore, right? So again, the general recommendation is true, the general rule of thumb is true, but always know the specific cost dimension of your services, and then plug those information that for your specific workload into your projection to understand how much a service is actually going to cost you. Last event, Werner gave us the frugal architect, which is the 7 rules that every architect should follow to be frugal in terms of thinking about your costs and whatnot. 2 specific laws that I really like is that architecting is a series of trade-offs, and also you want to pick services that aligns with your revenue growth, the dimension in which your revenue is going to grow as a business. I've done a lot of different WebSockets kind of implementations, and AWS has got a few services that gives you WebSocket support. You've got AppSync, API Gateway, IoT Core, and whatnot. They all charge you based on the same dimensions in terms of number of messages you send via WebSocket, but also your connection time. So how many people connected to your WebSocket server and for how long. And so if I've got, say, like a social network where the more users I have, the more connection time I'm going to see because people are going to connect to the app, they're going to maybe do stuff or not. And we find that revenue is going to grow along the line not with users, because most users just, they sign up, don't do really much. But we find that revenue grows along the line of engagement. So when people are actually doing stuff on the platform, they're more likely to stay around. They're more likely to turn into paying customers. And so your revenue is going to grow along the lines, the dimension of engagement. And so paying for connection time, therefore, by the number of users you have, is probably not the best idea in terms of matching your expenses with your revenue growth in terms of dimension. And so this is where, again, Memento is a really nice service because they give you these pops-up topics with WebSocket support. And the nice thing about them is that they only charge you for the messages. So only when users are doing stuff, so you fan out and send out messages via WebSocket, then do you actually pay. So this allows me to align my expenses along the same dimension as my business revenue. And speaking about picking cost-efficient services to partners to work with, I don't know if anyone remember this. That happened a few months ago. This social network blew up overnight. It went from about 0 users to 500,000 users per day, running on Vercel, and they got a bill for about $100,000. And this is because Vercel is, of course, built on top of Lambda, and so they put their own markup on top of whatever they are spending on AWS. And the problem is that their markup is pretty steep. They charge something like 7 times more than what the Lambda charges for the same cost dimensions. And so, also they're adding more things now. So now they even charge you for draining your logs from Vercel to some other platform, so you can search them in some other platform. So when it comes to partners, be really careful when it comes to working with partners that has got a huge markup on the underlying services that they kind of wrap their service around. We talk about how one of the things you can do to improve cost efficiency is by simplifying your architecture. Again, one of my architectural principles is that anything on my architecture should serve a purpose, should have return on investment, and I want to remove anything that's unnecessary. So we talk about how synchronous lambda-to-lambda invocations are bad, and if it's within the same service, you should just simplify and do both things in the same function instead. We talk about that there are legit use cases for async lambda-to-lambda invocations, but unfortunately, sometimes the nuances are lost, and I've had many customers who are basically doing this, except they heard about me talking about how lambda-to-lambda calls are bad, and so they put a SNS topic in the middle, even though they're not doing any fan-out. They're just there to prevent lambda-to-lambda calls. And so again, for things like that specific use case where you're really just doing lambda-to-lambda async invocations, and maybe you've got a good use case for that because you're offloading some other part of your code to be processed asynchronously, then just remove the SNS. Just stop pretending. Now, if you need to do that, that's fine, and you've got a good use case for that, that's fine. Again, everything needs to be sort of contextualized around what specific thing you're doing. Even though synchronous lambda-to-lambda calls are bad, there are use cases for asynchronous lambda-to-lambda calls. Again, my principle is that everything in my architecture must serve a purpose, otherwise it can go. And this quote, you've probably seen this already, that Grace Hopper quote that the most dangerous phrase in the language is, "We've always done it this way." Unfortunately, everyone's seen this already, so nobody says, "We've always done it this way." People just say, "I like it better." So again, there's so many cases where I've had people push back on things like Lambda function ULs, we're going to talk about in a minute, whereby instead of having API gateway to Lambda always, because that's how we've always done it, people just like it better, or they're not familiar with the fact that Lambda functions has got this feature called the Lambda function URLs nowadays, which allows you to create a public-facing, publicly accessible API endpoint for people to hit your function by giving them an HTTP API. You don't need the API gateway for building a REST API with Lambda anymore. This is great if you say you're not using all the features the API gateway gives you, and more importantly, if you're hitting limits the API gateway has in terms of, say, the 29 seconds, I don't know why it's not 30 seconds, but the 29 seconds timeout, or if you're building AI chatbots and things like that, and you want to do response streaming, and API gateway doesn't support that, so those are good reasons why maybe you want to consider using Lambda function URLs, which, again, don't have that 29 seconds timeout, and it supports the streaming response as well. The downside with using function URL is that now you have to handle all the routes inside of one Lambda function and what we call Lambda lifts. And there are pretty good support for that in terms of frameworks nowadays, but you do lose a few things along the way when you do Lambda lifts, in that you don't have fine-grained access control for per endpoint, but also maybe more importantly, you don't have the fine-grained metrics, and so for every single endpoint, and so you have to implement that in your application to be able to say, okay, every single route I'll record a custom metric so that I can then put alerts against every single route, so that I can get more fine-grained alerts when something goes wrong. Another thing to consider is that when you're doing Lambda lifts with function URL, you're kind of forced into writing using frameworks that's basically like Express.js and whatnot. So you want to pick frameworks that have that are small, so it doesn't have a big impact on your Lambda code starts. And with function URLs, it supports IAM authorization or public. So I think it's really good for things like just public APIs anyone can call, or internal microservices APIs that are meant to be called by another service in your AWS environment, so they can sign the request with the IAM profile, so IAM role, and so on. But if you do want to support user-facing authenticated API endpoints, you can still do that. Basically, with, let's say, Cognito, you can just authenticate against the Cognito's JOT and validate it in your Lambda function, which actually is pretty quick. As you see here, the first time you see a new JOT, it's just going to take 4 milliseconds. So if you do need to support it, is fine. Just keep in mind that when compared to, say, API gateway with Cognito authorizer, if there's an invalid request comes in, you still end up paying for that request. Whereas if API gateway you're using API gateway and it's handling authentication and invalid requests are rejected by API gateway, then you don't pay for those requests. So again, small risk of potentially being targeted for denial of wallet attack. Interestingly, you can also flip the other way. Instead of removing API gateway in front of your Lambda function, you can actually remove the Lambda function itself and just have an API gateway talking to, say, DynamoDB for simple like CRUD operations where you're not doing much business logic. You can find the API gateway can actually talk to pretty much every single AWS services. Essentially, it can just make a AWS SDK call for you to specific services. Why you want to do that? Well, by removing Lambda from the architecture, you remove the cold starts, impact on whatever your P99 latency, but also you remove any cost associated with having a Lambda function, those Lambda invocation requests and whatnot. And you can go beyond just APIs as well. For example, I can have an API gateway, doing a pull request, handling a pull request by calling pull item against DynamoDB, and then I can use the event bridge pipes to then pipe the events and send them to event bridge bus, so I can then build the application that reacts to those events. But maybe I don't want to handle DynamoDB change events. I want to handle a domain event, so I can have a Lambda function to transform the event from, say, item inserted to user profile created or something like that. A more domain-specific event that I want to handle with a shape that makes more sense for my application. A good saying that we had at the start of the whole serverless movement is that you want to use Lambda functions to transform data, not to transport data. So if you're just taking data as it is, not doing anything with it, and just putting it somewhere else, you can have services like API Gateway do that for you, or Event Bridge Pipes. And in fact, nowadays, you can also have data synchronized between DynamoDB and OpenSearch without writing custom code using the no-code ETL, which I do like, even though it's kind of a both in terms of how you configure that in the CDK and the CloudFormation. There's also other services that can support this pattern. AppSync can talk to different services without you having to write custom code. Same goes to step functions, can pretty much call every single AWS services without you having to write a Lambda function. And again, I go back to the same principle I said many times already, that everything on my architecture must serve a purpose. If I've got some business logic I need to run, I need to do some custom transformation, great. Put a Lambda function in there. But if I'm just taking data as it is, just dump it into DynamoDB, I can ask API Gateway to do the validation for me, then I don't actually need to write a custom Lambda function just for shuffling data from one place to another. So those are 11 ideas that you can use to look at your architecture and try to improve your serverless architecture and see if you can improve the cost efficiency for said architecture. And yeah, if you've got any questions, please feel free to let them, submit them, and then I'm happy to pick them up now. Thank you very much. And if you've got any questions, just come to find me afterwards.
There are many, eh? There are many. So first of all, congratulations on the talk. Many people were asking if they were recorded. And yes, they are being recorded. We have Stevie and Alec over there, so please, round of applause to them. Stevie, no la pierdas esta, que esta la quiere la gente, o sea que no la liéis aquí. Okay, I'll try to do some of these. First one is there any, easy way to visualize the costs in AWS that you can recommend, or it's just experience and...
There's a couple of services. Obviously, you have the AWS billing, which has got a lot of information, but it does require... It's not the easiest thing to use. So there's also a service called the Cloud Zero, which I actually really like because one of the things they do is that they track the cost allocation, the cost per SPY service, and they track how it changes over time, and they can give you an alert to say, oh, suddenly your EC2 cost has gone from a couple $100 to a couple $1,000 a month. Do you guys make some specific architecture changes that created that difference? So check out Cloud Zero. It's a really nice service.
Cloud Zero then. They're asking if you have experience bringing your own containers into the Lambda runtime, and how would that impact in execution time and billing, if any?
Yeah, so with a Lambda, you can also, instead of uploading your code in a zip file, you can also say, package all of your code into a container image, and then have Lambda function basically run from that container image. The benefit of that is that with the zip file, you're limited to 250 meg in terms of the package size, artifact size, but with the container images, you can go up to 10 gig. So for a lot of the machine learning workloads, they need to run the things like those big models and whatnot. You actually need to use container images. And they've done some really clever optimization on caching for the container images. And so on the functions that are bigger than, I think, about 150 meg or something like that, the package size is actually faster to load cold start on the container image than it is on the Lambda on a zip file itself.
Even faster. Okay.
So on bigger functions, it's faster.
Yeah. OK. Then what infrastructure do you recommend to save money if you need to keep the logs?
OK, if you need to keep the logs, then look for some other platforms that actually. I mean, CloudWatch is actually quite a good, cost-efficient platform if you want to keep all of your logs, but it's kind of geared towards a single account. I know they've added support for cross-account, but the way you do that is kind of clunky, and they also tie into access to the AWS console and other things like that. So I wouldn't recommend it. So I would definitely say look for something like Lumigo or other platforms that give you a good cost in terms of ingestion and queries if you do need to keep your logs. But I think keeping logs long term is not that great an idea. If you've got a specific reason, then come ask me afterwards. I'd like to talk about that.
And then the final one, they're probably asking for a number or some percentage of usage. When do you recommend Lambdas instead of dedicated servers? It's hard to put a measure, of course.
Yeah, it's hard to say, but I guess with Lambda, just in terms of cost, right? So if you're talking about just purely on cost basis, then when you've got something that's running fairly low throughput, Lambda is just more efficient in terms of cost. But I think more important for me is thinking about developer productivity. As someone that works mostly with Lambda, I can just do a lot of things very, very quickly versus, say, having to manage containers. And if you're in an organization that has got dedicated DevOps or platform team that can do a lot of that heavy lifting for you, then I think that becomes more of a case of, OK, whatever it is we're building, do we get that productivity by using Lambda? And one of the nice things that Lambda gives you is the fact that a lot of that security concern that you have to worry about in terms of patching machines and all of that, that's all handled for you. So a lot of my clients in the enterprise space, like banks and whatnot, they go to serverless because, well, they go serverless first, not serverless only, because in terms of compliance, it's a lot easier to meet all the compliance requirements with Lambda than say, OK, we manage these machines, and we have to know when was the last time it was patched, who has access to it, all these other things. You just have to, becomes non-applicable when it comes to using Lambda. So Lambda gives you some really good scalability, redundancy, and security out of the box, but per request, as high throughput, is more expensive. So you kind of offload, you can kind of balance that against how much productivity you get as a developer, and that depends on the skill set you have in the team and how good your platform is at taking care of all the other things that you're going to worry about, like security, patching, all of that other stuff. So I can't really say like a specific number, but personally for me, if you are hitting something like, I don't know, 1,000 requests per second, definitely go to containers because it'll be more cost efficient at that point.
And we ran out of time, so thank you very much.
Hopefully
you'll stay for some...
Yeah, I'm going to be around, so you're going to come find me afterwards.
All right, see you later, folks.
So thank you very much.